Hey, this is Pythagoras revision part 3, and we go to the third block of questions related to traveling problems, for example here. So two batch workers, so we are here, two batch workers actually set up from base camp at the same time and working right angles to one another. So let's say we have a starting point and two persons just setting off from the base from this point and walking right angles to one another. Let's say one is walking towards north and another person is working towards east, right? Okay, one works an average speed of 5 km per hour and the other at the average speed of 4. So we are given speeds and we can always connect with the distance using the simple formula. So distance or displacement, yes, if you just have reference to physics, simply speed times time. In this case, speed can be varying, right? It might be like not constant, it might be changing, so that's why we take an average speed. So this is average speed times time. So find their distance apart after 3 hours. Okay, let's say that per 3 hours one traveled this distance, say d1, and another person traveled distance d2. All right, so you need to find their distance apart 3 hours after. So what we can say, we need to find this distance. Okay, that's again Pythagoras, right? Because we have right angle triangle. Okay, let's calculate d1 and d2 using this formula. So we simply need to say that according to d1, so according to data, we have 5 km per hour. So this is 5 km per hour. And let's say the second one is moving with the speed 4 km per hour. So for 3 hours, we have time for both of them, 3 hours. So in order to find the distance, we simply, for the first one, we simply multiply 5 by 3, which is 15. So km. And distance 2 is simply 4 times 3, which is 12 km. And now we have a triangle with sides 15 and 12. So I just erase that, and instead I'll put basically only values for distances, right? So let it be 15, this is 12, and we need to find d as hypotenuse. Now go back to the Pythagoras and we'll get 15 squared plus 12 squared. So distance squared is 225 plus 144. Okay, so let's calculate it quick. So we'll get addition, and we need to calculate square root also. So square root of plus 144. Okay, that's around 19.21 km. Alright, that's the distance. Okay, next one. To get to the school from her house, Elle walks down Bernard Street, then turns 90 degrees and walks down Thompson Road. So until she reached her school. Okay, so let's see. So first of all, we need to draw a map, sort of. Say this is house, right? And she walks down Bernard Street, then turns 90 degrees. Okay, let's say this is Bernard Street, all right? Then it turns 90 degrees. And here is like Thompson Road. until she reached her school gate. Okay. She walks twice, so this is school. This 90 degrees turn. So basically, her route is simply two segments, which are 90 degrees to each other. So she walks twice as far as Long Bernard Street as she does along Thompson Road. Okay, so she walks twice as far along Bernard Street as she does along Thompson Road. Okay, so what we can do, we can complete, let's say if Bernard Street, let's say Thompson Road is just X, so Bernard Street twice, that means 2x. Okay, and here we just connect with straight line indicating distance. So Alice's house is 2.5 km and straight line from his school gate. How far Al walks along Bernard Street? Okay, so we need to find 2x. But first of all, we completed Pythagoras theorem, so we'll get the following. 2.5 squared equals 2x squared plus x squared. Okay, so in order to calculate, we'll get the following. So 2.5 squared, we'll get 625 equals 5x squared. Okay, then we divide by 2. Sorry, divide by 5, which is 125. This x squared, and now we're taking the square root of the whole square root of 125. So we'll get around 1.12 km. So that's what about Thompson Road, right? But we are supposed to find how long does L walk along Bernard Street, so we just double this quantity. So we'll get 2 times 1.12 km, so we'll get 2.24 km. Okay, that's the answer, and that's how we can figure out the distance. And you see the link again, we connect Bernard Street lines with the Thompson Road lines. That's how we can connect two sides basically. Okay, so let's go to the next one. So the next one is here. So boat A is 10 km east of the boat B. Okay, so I'll just erase first of all. Okay, so what we have two boats. Boat A is 10 km east of boat B. So we got two boats. Boat A travels 6 km north. So that's why we put that as boat A. It travels 6 km north, right? And boat B travels 2 km west. But initially, the initial distance is 10 km, right? So boat A is 10 km east of boat B. So that's why we need to do the following. So we just transfer that here and figure out that we also have boat B travels 2 km. So yeah, 2 km west. So that's boat B, and it travels 2 km to the west. So this is north direction, this west direction. Okay, how far apart are the boats now? Okay, so this is initial distance. I highlight as the blue one. So this is initial distance, which is 10 kilometers. They're apart 10 kilometers. So this is boat B, this is boat A. So after traveling 6 kilometers, so boat A will be somewhere here. That's the position of boat A. And so position of boat B, like 2 kilometers here. Let's say it's here now. And we need to find the distance between the boats. Okay, so I put this blue one. Okay, that's the distance that we need to find. All right, so again, right angle triangle, because direction north and west, they're at 90 degrees. So how to find the distance? So we need to count the total length. Basically, the bottom length, the bottom legs is actually 2 and 10, it's 12 km, and this is simply 6 km. Okay, after traveling. So we've got triangle with sides 12, 6, and d distance. So we can easily figure out using Pythagoras again. So we'll get d squared equals 36 plus 144, which is 169. That's d squared, and now d is square root of 169, square number, so the answer is 13 km, 13 kilometers. After they traveled corresponding distance 2 and 6. Okay, so that's an idea. Oh, actually, yeah, I roughly miscalculate, so it's gonna be like 170. Yeah, 170. So even 180, I guess. Yeah, let's check one more time. Yeah, 6. Yeah, 180. And now we take the square root, so distance a bit more than 70, then 13. Let's calculate square root of 180. That's about 13.42. Okay, yeah, correct, please. That was my bad miscalculation. So that's why distance is going to be 13.42 km. Okay, but the logic stays the same. All right, so, and here is the last block here. I think we can cover it right now. So, because I promised it's the last video. Okay, a yacht sailed 5 kilometers due west and then 8 kilometers due south. How far? It's from starting point. All right, so just simply 5 due west. Okay, that's west direction. 5 kilometers from initial point, and then it turns and sails due south. Okay, the south and 8 km. So again, how far is from starting point? You need to calculate this distance. Again, apply Pythagoras and you'll get the answer. So d squared is a squared plus 5 squared. So d is square root of 64 and 25. Okay, that will be the final answer. And just simplify and calculate. So next one, cyclists at sea traveling towards B. Okay, how far will he have to cycle before he is equidistant from A and B? So equidistant from A and B means that he will be at the point, so that the distance to the point A and to the point B will be the same. Okay, so let's see, cyclist 2 kilometers here, so 4 here, 10 here towards B. So he's traveling here. All right, so I guess this is the point, right, when the distance is to B and to A will be the same. Okay, so that's why how how far will he have to cycle before his equidistant. So basically what you need to find, I put as red, you need to find distance from initial position to some point, okay? So that distance is what you need to find. Okay, because we have equidistant points, so equidistant segments, let's say this segment, this point K, or let's say C star, right, where it's now. So we know that A C star is equal to C star B, okay? Those two segments the same. And what we can figure out, so we can figure out the following. First of all, if we mark this as x, so it's also x, first of all, we can find, I think, x, right? At least we can figure out the equation. Let's say this part from point K to C star is y. So we just want to input new variable. And let's say this is y, okay? So KC, let's say this is x and KC star is y. We input new variable. Okay, what we can figure out, so from the triangle AKC star, we can figure out that we have y, hypotenuse x, and KA is 4 kilometers. So we can figure out that x squared equals to y squared plus 4 squared, which is 16. Okay, that's the first equation. We also know that the total distance from C to B consists of several parts. It consists of the segment 2 kilometers, then y, and then the left is x. So we can complete a new equation for that. So the new equation for that will be 10 km actually equals to 2 plus y and plus x. So we can connect that 8 is y plus x, and of course we can figure out, let's say, what we need to find. We need to find actually y and x both, okay? So that's why we consider this equation and this as the system of equations. So we check it as the system, and from the second equation we can express x is 8 minus y and just plug here back into the first equation. So after the plug-in into the first, we'll have the following: 8 minus y squared equals y squared plus 16. Okay, let's simplify that. So what you simply need to do is to expand brackets. So I'll use the formula a minus b squared, which is a squared minus 2ab and plus b squared. So we'll get a to be 8 and b to be y. So we use that and we'll get 64 minus 16y, right? And plus y squared equals y squared plus 16. Alright, so we can simplify that. Y squared will be crossed out and we're left with 16y equals 64 minus 16. So we simplify that and we'll get 48 equals 16y. So y is just simply 3 km, okay? So we found that y is 3. So now instead of y we can plug 3 here. And now in order to calculate x, we just simply, so we can put it back to the system actually. For example here, and we know that x is actually 8 minus 3, which is 5 km. So x is 5 km. So we found both of them. So we know that x is 5 now. But actually you actually need to find how far we'll have to cycle before his equidistance. So basically you need to find this distance from C to C star. C star is actually 2 and 3 km together. It's 5 km. Okay, actually you weren't supposed to find x, but okay, we found it. But the final question is just find distance C star. Okay, it's 5. Okay, let's go to the last question here. And hence we will cover the whole Pythagoras related at least to 2D, two-dimensional problems. Alright, so a street is 8 kilometers wide, and there are 3 lights positioned either side of the street every 20 meters. Okay, so let's see. How far the street light acts from the street lights. Okay, so actually what we need to do, we need to say that this is the width of the street, i.e. 8 meters. And you know that lights position every 20 meters, so means that this distance is 20, so they position equidistantly from each other, so means everywhere 20 meters. Okay, how far is street light X from light A? Okay, so this is 8, and what you're supposed to find is just simply, so one time, this distance. All right, so we have right angle triangle, so this distance AX squared is 20 squared plus 8 squared, so we'll get AX as square root of 464. Okay, so next one from B. So from B it's just simply 8, right? Because it's just simply split it by the width of the road. So Bx basically is 8 meters. Okay, so next one from C. This segment is actually the same as AX, so we can state that XC segment is the same as AX, so it will be the same distance. And from D, so from D, I erase all the lines. So we need to find this distance. Okay, now we have just another leg, 20 and 20 together, so we'll get 40, and that's why x, the distance, is square root of 8 squared plus 40 squared. Okay, so xd is square root of 1664. Okay, that's the answer. All right, so we've done everything within this topic. I think it's powerful revision, and from there you can go further in probably 3D Pythagoras, where you have like 3D shapes, 3D solids, and try to apply your knowledge that you've got here, and try to apply to, let's say, try to expand it to a new topic, to just new dimension. All right, thanks for watching. Subscribe, don't forget to subscribe to be in touch with me and with the latest videos and updates. So see you later.